Hi everyone, let's work on general solutions together this time. We have learned before how to find inverse values for angles between 0 and 2 pi. So when we solve this problem, we're going to find two answers for this one. But today we're going to learn that there are not only two answers, but there are infinite number of answers, and we're going to learn how to find a general solution. Okay, so first of all, let's solve this problem the way that we have learned before, and then we're going to learn general solutions. So here we have sine of an angle equal to radical 3 over 2. It's positive, so the angle should be either here or on the other side. So here in this one, this is my reference angle, and I'm going to have my right triangle, and then sine is opposite over hypotenuse. So opposite side of this angle is radical 3 and hypotenuse is 2. I use the Pythagorean theorem and I can find the other side as 1. So I see the ratio of the sides of a special right triangle of 30, 60, 90. Opposite radical 3 is 60 degrees or pi over 3. So I found this reference angle. Now the angle itself is going to be starting from here and ending at the terminal side. So the first answer is pi over 3. Now the second answer is here. The angle could also be on the second quadrant. So this is my reference angle and this is the right triangle. Opposite is radical 3 and hypotenuse is 2. The other side will be 1, or basically negative 1 because it's on the left side. And I see the special right triangle of 30, 60, 90. And this side, this angle is pi over 3. So if this is my reference angle, the original angle is going to be this one. So to find this distance, I want to take pi, like half of the circle, and subtract this from that, and I can find this distance. So answer number 2 is pi minus pi over 3. I can find the common denominator in this way. We have done this before. 2 pi over 3 is my second answer. Okay, so this is what we have learned before. But here's the point. These are not the only answers. These are not the only angles that sine of those angles are equal to radical 3 over 2. Basically, we have infinite number of angles that sine of them is equal to radical 3 over 2. How? So let's say I start from here for this angle, for the angle number 1, the answer number 1. Let's say I start from here. And instead of stopping at this point, I'm going to make one full circle and then stop at this point. So the sine of this angle is also radical 3 over 2. I could also make another full circle and then stop here. I could make another one as well and stop here. So in this way, I can make as many number of circles and find my angle again. So that's why we say we have infinite number of solutions. Now I can write a general solution for this. Instead of writing infinite number of angles here, I'm going to write a general solution. How? The easiest way is to add 2 pi as many times as we want to our angle that we found here. So the general solution is pi over 3 plus 2 pi times n. This n is the number of the times that we're making this circle. Could be 1, 2, 3, 0, or any other number. Okay? And for this one, again, the same way. Instead of starting from here and ending at this point, I could make one full circle, then stop here. Another circle, and then stop here. So the same way, I can make as many number of circles, then stop at the terminal side. So the general solution in this case will be 2 pi over 3 plus 2 pi times n. So if the n is equal to 0, my answer is going to be just pi over 3 for this one and 2 pi over 3 for this one. If n is equal to 1, it's going to be pi over 3 plus 2 pi, which is pi over 3 plus, I'm going to make a denominator of 1, multiply by 3, plus 6 pi over 3, so it's 7 pi over 3. And for this case, it will be 2 pi over 3 plus 2 pi, which is 2 pi over 3 plus 6 pi over 3, and it's equal to 8 pi over 3. And the same way I can choose n equal to 2 and solve it again. So that's how we find different number of solutions. Here it's asking to find the first 3 positive values, so they could be this one, and let's say this one, or even this one. So this is how you find the general solution and the first positive values. Let's try this one together. So in this case, tangent is a negative value. So the angle should be either here or on the other side. So this is my reference angle and the right triangle. Tangent is opposite over adjacent. Since there is no denominator, I'm going to put a 1 here. So opposite side is radical 3 and adjacent side is 1. Which one is going to take the negative? This one, because this is on the left side of the x-axis. Now, I can use the Pythagorean theorem and find the other side, which is 2. That means I have a special right triangle of 30, 60, 90. Opposite radical 3 is 60 or pi over 3. So this is my original angle, which is pi minus pi over 3. So the first angle is pi minus pi over 3, which is 3 pi over 3 minus pi over 3. It's 2 pi over 3. So that's the first answer. But now I'm going to change this to a general solution. So the answer is 2 pi over 3 plus 2 pi n. That's the first general solution. Now the next one could be here. And here's my reference angle, triangle. Opposite side is radical 3, adjacent is 1. This time the negative goes with this one because it's below the x-axis. Hypotenuse 2, and here I'm going to see pi over 3. So the reference angle here is going to be this one. The reference angle is pi over 3. The original angle is this. How do I find the original? Just consider the full circle and subtract this to find the rest of it. So this will be 2 pi, which is the full circle, minus pi over 3. So this is 6 pi over 3, 2 pi over 1. If I multiply top and the bottom by 3, I'm going to get 6 pi over 3 minus pi over 3, and it's equal to 5 pi over 3. So this is my second solution. I'm going to change this one as a general solution again. Just add 2 pi over n. Okay, so these are the general solutions. Now if it's asking us to find the first 3 positive values, so I'm going to say if n equal to 0, then the values are going to be 2 pi over 3 and 5 pi over 3 because n is 0, so these two will just cancel. And if n is equal to 1, it's going to be 2 pi over 3 plus 2 pi. So n is 1, so this will be 2 pi. So this is 2 pi over 3 plus 2 pi will be written as 6 pi over 3 and is equal to 8 pi over 3. So the answers are 1, 2, and 3. I can stop here. Now let's work on the next example. Okay, so in this case, we have cosine of angle of something is equal to negative 1 over 2. So we're looking for x. X is going to be basically, to find x, I am going to take the inverse of both sides. So apply that. These two cancel each other, so I'm going to have x on one side and on the other side cosine negative 1 of negative 1 over 2. This is what we have. Okay, so the angle has a cosine which is a negative number. So cosine should, so that means the angle is either on this side or this side. So let's work on this one. This is the angle, reference angle, and here we have the reference angle and the triangle. And cosine is adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2. The negative goes with this one because it's on the left side of the x-axis. We can use the Pythagorean theorem and find the other side, which is equal to radical 3. Now, this is the ratio of the special right triangle of 30, 60, 90. Opposite 60 is radical 3, so this side is pi over 3. So I got my reference angle, and now the original angle will be pi minus pi over 3. So to find this distance, I take the half circle, subtract pi over 3 from that, pi minus pi over 3. So it will be 2 pi over 3. Now, what is my general solution? 2 pi over 3 plus 2 pi n. And the other angle could be here. Reference angle, special right triangle, opposite, the adjacent is 1 and hypotenuse is 2. And the negative goes with the 1, which is on the left side, so we already had this. And they use the Pythagorean theorem. This side will be radical 3 and negative because it's below the x-axis. Now we have a special right triangle of 30, 60, 90. This side is pi over 3 again. So what is my reference angle? It's from here to here. So the other angle will be, the original angle will be pi plus pi over 3. So it's 3 pi over 3 plus pi over 3, and it's 4 pi over 3. Now the general solution is 4 pi over 3 plus 2 pi times n. So these are my general solutions. And now if I make the n equal to 0, the solutions are going to be 2 pi over 3 and 4 pi over 3. And if n is equal to 1, it will be 2 pi over 3 plus 2 pi. And this will be 6 pi over 3. So 2 pi over 3 plus 6 pi over 3 will be 8 pi over 3. So I can rewrite this as 8 pi over 3. 8 pi over 3. And the other one could be, if n is equal to 1, 4 pi over 3 plus 2 pi. And then again, I can write the 2 pi as 6 pi over 3. And if I add them, it will be 10 pi over 3. 10 pi over 3. So we found 4 solutions here. So this is how you find the general solution, and from there you can find as many number of answers as you want. Okay, have a great day.